We know what firmware it's running. And this is without even logging in.
You literally just typed something in Google and you found this. Yeah.
Exactly.
You know, I don't want to lose my channel. Hey everyone, it's David Bumble back with Occupy the Web. For those of you who haven't watched our previous videos, he's the author of this book, fantastic book if you want to learn Linux from a hacking perspective. He's also got this book, Getting Started Becoming a Master Hacker. Occupy the Web, welcome.
Thanks, David. Thanks for having me back again.
This book's getting updated, is that right?
It's getting updated, and it's going to be republished by No Starch Press under a new name. It's going to be called A Cyber Warrior Handbook, and it's going to be totally rewritten with new tutorials, and it's going to be more targeted towards the cyber warrior than just the beginner hacker. It was originally scheduled to come out later this year, but the war kind of got in the way. The war has been taking a lot of my time that should have been spending on updating that book. But hopefully it'll be out this winter sometime.
A lot of you have given feedback about, the content that you want to see. And I'm really happy to announce that Occupy the Web is going to be doing a series of technical videos. So we're going to dive into like a bunch of technical details. And as part of this series, we're going to be looking at Mr. Robot hacks. Occupy the Web, on our previous video, you were telling me one of the problems with YouTube videos and perhaps with Mr. Robot and all these movies is, it's not realistic. So I'm hoping we can take like a Mr. Robot hack and you can show us like how it actually works in the real world.
Yeah, I'd love to do that. And let's start off with one of the best hacks in the show. And one of the things I'd like to do is to explain why I like Mr. Robot, because I like Mr. Robot because he does real hacking.
It's not because of the drugs, yeah?
It's not because of the drugs, right? Drugs are a side benefit. It's because it's real hacking. It may be in a more compressed time frame than reality. That's because it's a TV show and they can't spend hours and days just like on YouTube videos. But if you watch very carefully, he's actually doing hacks that are largely, not all, largely realistic. It's really one of my favorite TV shows of all time. Not only because it's a hacker show, but it's got Rami Malek. Those of you who may not be familiar with Rami has been an actor who's been around a little while, and he's the guy who got the Academy Award for Best Actor for playing Freddie Mercury in Bohemian Rhapsody. Mr. Robot is really what made him famous. This is really what launched his career, was this TV show. And basically it's the story of a young man who probably is on the autistic spectrum. At least that's my interpretation. He displays a lot of characteristics that we associate with Asperger's, his kind of asocial behaviors, his inability to look people in the eye. He's kind of really sensitive to touch. He doesn't like to be touched. He's very focused on what he's doing. These are all typical traits of somebody on the Asperger's spectrum. I can relate to this. I mean, if it's any help to you, that's probably very close to what I was when I was his age. Okay,
that's amazing. Yeah,
and like him, he struggles with this kind of being able to relate to other human beings. And I've worked on it all my life, and I think I've done okay on trying to be more social. So not only can I relate to him as somebody who's a hacker, but I can also relate to the kind of things he's suffering with, the things that he's trying to deal with in his everyday life. Obviously, I love this show. And if you want to know more about my personality, you can see a lot of me in Elliot. And Elliot is the main character, Elliot Alderson. We start off the show where he's basically working as a cybersecurity engineer for what he refers to as Evil Corp. And Evil Corp is a very large corporation who does a lot of bad stuff. They're probably responsible for both the death of his father and his best friend's mother, Angela. And he struggles with his idea that he's protecting this evil corporation. His job is to protect a company who he hates. So we see this constant struggle in his personality of what and how he should do this. That's kind of the beginning. What we're going to do today is we're going to address, I think it's episode 6, season 1, episode 6, if I remember correctly.
That's right, yeah.
And the reason I like this
I
particular
made sure about that, so I made sure I watched it today to do my research. So you did your research today as well, yeah?
my research was enjoying watching Mr. Robot, which I could watch over and over and over again. So I like this particular hack, and those of you who know me and who are my students or have been to my website know that I think that SCADA ICS is probably the most important area of hacking right now. These are the systems that run the world. Every facility, every refinery, manufacturing facility, electrical grid, these are all run by industrial control systems. And these industrial control systems are all run by what are called programmable logic controllers, PLCs. These PLCs are all very simple computers, okay, that allow the operator to basically, open valves, open doors, close doors. It runs the industrial world. I think it's been largely overlooked in terms of both security, cybersecurity, and the role that these plants will play in any kind of cyber war, which we're in the middle of right now. And we've seen the Russians attack repeatedly the industrial control systems of Ukraine. And, the Russians are feeling a little bit coming back at them right now. We won't go any deeper into it than that. In this episode, this is one of the most complex hacks that Elliot does, and there's a lot of reasons to like it. One, because it uses different technologies. It ends up where he's trying to hack his girlfriend out of prison. And of course, the prisons are industrial control systems. So what we're going to do is we're going to walk through what happens as Elliot tries to hack Shayla. Shayla has been kidnapped by the drug dealer Vera, is his name. And Vera is an evil guy. He's taken Shayla and he's holding her hostage. And he's told Elliot that he's not going to let Shayla go until Elliot hacks him out of prison. And of course, Elliot says, "You got to be kidding, right? This is crazy. I can't hack you out of prison."
Yeah, he did it in one day as well. Is that right? Yeah. Yeah.
Exactly. So
One day. So Vera was in jail, and
right,
Shayla was held hostage by his group. Is that right? And he had
that's
to
right.
get Vera out of jail, but like tonight.
Tonight,
Yeah.
and he tells Vera, "I can't do that in one
Yeah.
day." And that's realistic. I mean, he's telling him that this kind of hack will take maybe weeks, months. Vera's not buying it. Vera knows he's got to get out of jail tonight, and he insists upon it. And so Elliot has to come up with a solution. And the first solution he comes up with is that he has Darlene. Darlene's his kind of sidekick.
I think that's what they used. Yeah, the rubber ducky.
Well, they tried. Yeah, they tried to
They
use
tried this. Yeah.
essentially a rubber ducky. Yep. I mean, you can actually reprogram the firmware in any thumb drive to do what the rubber ducky does. So, rubber ducky is an example of a reprogrammed thumb drive that
You,
when you put it
you're
when
gonna
you
have to
put it
show us
in.
how to do that. If like take any thumb drive to do something like that. Maybe that's for another video.
That's for another video because
Yeah.
that's beyond what we can do right here. But
Yeah.
basically, you have to upgrade the firmware on the thumb drive so that it appears to be a keyboard. That's all it is. There's all kinds of different thumb drives, right? And so your thumb drive, normally the firmware in it tells your system that it's a storage device. You can flash the firmware of the flash drive and give it the information that it is a keyboard. And so now when it plugs into your machine, it's recognized as a keyboard, and then the rubber ducky or the flash drive can send keystrokes into the system. So you can immediately start sending keystrokes in and do basically whatever you want with the system. So you can program keystrokes already in there. And that's the first attack that they try. Okay, is that Darlene uses a exploit from I think they refer to the company as Rapid 9, which is kind of a reference to Rapid 7, who owns Metasploit. And Elliot kind of scolds her and says, "Hey, what are you doing using, a known exploit? Because it fails. It fails because the antivirus detects it." So let me back up a little bit. Darlene leaves these thumb drives all over the parking lot of the prison, hoping that somebody will pick it up and put it in a machine inside the prison. Because Elliot recognizes that prison systems are offline. The problem he has is, how do I get inside the prison network? Most SCADA systems are online. Prison systems and a few others are offline, like things like dams and bridges and that type of thing. Usually they're offline, but the prisons are offline. So he realizes he has to get inside the network. He can't reach it from the outside. So the idea is to drop these rubber duckies, like flash drives. Somebody will pick it up, put it in the machine, and in the show, one of the guards does that as the commands within the flash drive are beginning to take over. His antivirus detects it and stops it. So that attack fails. And one of the beauties, okay, of Mr. Robot is it shows somebody failing in their attack, right? I mean, most shows don't show that. In reality, hackers spend a lot of time on failed attacks. In an earlier episode, we talked about the Stuxnet attack and how that took 3 years. And it failed many times during that 3 year period. And they kept on updating it to get it to work. It's more realistic that you see somebody actually failing, which you don't see in most movies and TV shows with hackers. They always immediately get into the system in 30 seconds or less. So he fails initially. So he has to come up with a new plan.
Just to ask you the question, that rubber ducky piece was real world, is that right? Or close to
That's
real
real.
world?
It's
Yeah.
real world. Yeah,
Yeah.
it's the rubber ducky you can buy, as you showed. You can buy them at what Hack5 has them,
Yeah.
I think.
Yeah.
But you can build your own. Either way, you can do it. It's realistic, and it fails because she used a known exploit that was detected by the AV. That's realistic. If you use a known exploit, it's going to get detected by the AV. Now, one of the things that she might have done at this particular point in time is she might have gone ahead and try to obscure the exploit and try to get it past the AV. She complained that she said, "Hey, I didn't have time to do this. You gave me like an hour to do it." And she's right. She couldn't build an exploit in an hour. Well, one of the things that was also kind of interesting at this point is that notice that Elliot is trying to SSH into the system. That seemed kind of odd to me, because if I were doing it, and most hackers will do this, is that they'll put in a reverse shell that will call back to him. So instead of him calling in, they have a reverse shell that'll call him and connect to him. I thought that was kind of unusual that they did it that way. So Elliot's got this problem now. He's got hours, just hours, to be able to take down the prison system. And so he still hasn't figured out how to get inside the network. So he goes and visits Vera in the prison, and he takes his phone with him. And he uses his phone to scan for all the Wi-Fi networks. So he's using his phone. And those of you who have used AirCrack are familiar with this kind of scanner. There's a number of Android and iPhone applications that'll do the same thing. And what you can see here is that he's scanning on Mon0. So that's the interface. And notice that he's pulling up, it says ESSIDs. These are really the BSSIDs. These are essentially the MAC addresses of all of the APs in the channel that they're on, and their encryption, and of course their power here. He sees, he goes back to his phone, he sees, oh damn, they're all WPA2. It'll take me days to be able to crack it. And that's accurate. You can crack WPA2s, but it's a time-consuming process. You can't do it in 30 seconds or 3 minutes.
Unless you watch my video where I show you to do it in 15 seconds.
Right, exactly. Exactly.
With a GPU. It's exactly right. It really depends how lucky you are.
It depends. Really, to be able to crack WPA2, basically what you're doing is you're trying to take a word list and match the word list to the password of the system. If somebody's used a very weak password, you can potentially crack it in a matter of seconds or minutes. I mean, if they've used, a password that's the same as the ESSID, you might be able to do it in a matter of minutes. But Elliot looks at it and goes, realistically says, I can't do this. I can't do this in hours. I need to find another way into the system. So he's trying to figure this out. He's actually walking out of visiting Vera at the jail. And while he's walking out, he sees on his screen that somebody is connected to the internal network inside the jail. And it happens to be a police car. So this gives him the idea. If I can get inside of his system, then I'll be inside of the prison's network. So the question is, how does he get inside the squad car's laptop? And that's where we get to Bluetooth.
Just before we go there, can I ask you about the WPA thing just quickly? So,
Yep.
reality versus movies. Which phone would you recommend? Is it Android? Or Android's going to be the easiest to do this kind of stuff, or do you install Linux or something on a phone?
You can either install, there's NetHunter that is basically Kali on a phone, or you can there's applications you can just download both for the iPhone and for Android that'll do the scanning like in this picture that we just put up here. It doesn't tell us what this is, what the scanner it is, but there's a number of them. Just go to the iPhone store, go to the Google Play Store, and look for Wi-Fi scanners, and there's a whole slew of them that'll do this.
Yeah, so that's just showing you the networks available. It's not letting you crack them. Is that right? Or there's a specific app that you would use on a phone to crack it? Or I mean, it's going to take forever. So you're going to push that off to a GPU or something. Yeah.
What you want to do is you want to capture the handshake.
Yeah.
Right. So he's just scanning for the networks. And then if you're using Kali, you want to go ahead and use Arrow Dump. And Arrow Dump will allow you to capture the handshake between the client and the AP. And then once you capture that handshake, inside that handshake is the hash of the password. And that's what you try to crack with. He realizes that's not realistic. He can't do that. So he realizes that the police car has a dedicated cellular connection to the network inside the jail. And he sees that when he's walking out of the jail, and he sees that that police car is connected inside that network. Immediately he says, oh, I have a path inside the network of the jail. The path is I have to get inside the laptop inside the police car. That's more difficult than you might think, right? Maybe you do think it's difficult, and it is difficult, right? So here's where, things get a little sketchy here. He's using HCI config to scan for the Bluetooth connections. And let me just show you how that works. All right, so what I've done is I've just downloaded BlueEasy. It's out of the repository at Kali. And what it does is has multiple tools in it for Bluetooth hacking, okay, and Bluetooth manipulation. What I've done is I've got actually an external Linux Bluetooth adapter in the system. So once I have these tools embedded, then I can go sudo, and then it's HC. This is what Elliot's doing in the show. HCI config is just a tool similar to IF config that'll pull up all of the Bluetooth connections, and there it is. It shows me that my Bluetooth adapter, and yours is probably going to say down when you start, so you have to start it. And to do that, you go sudo HCI config, just like with IP config, go up, and now you got it up and running. You can see here's the MAC address. Okay, let's go back to
Did you say you've got a dedicated Bluetooth adapter connected to your laptop? Yeah?
I did.
If you can give me the device name, I'll put a link below so people can go and buy that if they want.
This one is actually a Panda. You can buy them on Amazon or Egghead or any of the various electronic stores. So look for ones that have Bluetooth drivers for it. Some of the Windows ones won't work. Some of them will tell you they'll work in both. I've tried a number of them out, and usually the Windows ones simply won't work in Linux. So make sure you get a Linux Bluetooth adapter. If you're running on a virtual machine like I am right now, of course, you have to go ahead and attach it. So you got to go up here. This is VirtualBox. Got to go up to USB, and then make sure that, see, it says your Cambridge Silicon Radio. That's the chipset. This is manufactured by Panda, I believe. You also want to make sure, even before you get to this part, is you want to go LS USB to make sure what's connected to your USB. And you see this is what's connected to my USB. And here's my Cambridge Silicon Radio. Of course, Cambridge is a British firm. You see the LTD right there. And then let's go ahead and clear our screen. And so sudo HCI config. Let's look what it tells us. It tells us it's on a USB bus. It's a primary type. The name, just like when you do IF config, then it gives a name to the adapter. And the name is HCI0. Yours might be HCI1. It might be HCI2. but usually it's going to be HCI0, just like your WLAN is usually WLAN 0, your Ethernet adapter is going to be ETH 0, and then it gives you the address. This is the MAC address of the adapter. So this is where you see in the, I'll go back to what he was showing on the show. You can see right here, HCI config, HCI 0 up. And he has two adapters. He's going to the second one and taking it up as well. And then he's got HCI config, and he's pulling up the information just like what we've done here. What we want to do now is that within this group of Bluetooth tools, there's a tool called HCI tool. I'll just show you what it can do. Pull up the help screen. And so, of course, this is the help screen. That's what we're looking at right now. And it'll display the local devices. Okay. Inquire any remote devices. It'll scan for remote devices. And this is the next step that Elliot does, is that he goes ahead and uses this tool to scan for Bluetooth devices in the area. And there's a number of other things. You can submit arbitrary HCI commands. You can do inquiries. But right now, we're going to kind of just do what Elliot did. And that's what he did, is he went ahead and did HCI tool scan. And it begins to scan. And what it's doing is it's looking for other Bluetooth devices. It pulls up one device, and this is these are the speaker system in my office. Let's go ahead and turn on some other Bluetooth devices and see if we can see them as well.
It's really impressive that the show is so true, though, and I can see why you like it.
Oh, I love this show, and so I'm glad that you had agreed to do the hacks, because there's a lot of great hacks in this show.
No, we must cover them all, I think. So let's just ask the audience, do you want Occupy the Web to do like all of them? Just put in the comments below the ones that you really want to see, and we can perhaps prioritize some over others.
I'm going to go ahead and do another scan. I just turned on another device. This is very similar to, like I said, any type of scanning tool. Sometimes it's going to work, sometimes it's not, but you get the idea that there we go. Okay, I just turned on another speaker system. So this is what Elliot's doing. He's going out and he's scanning for these devices. What he does is he finds the device, the Bluetooth device, in the laptop of the police car. Then he does an HCI tool inquiry. Let's do that. Sudo HCI tool inquiry. And this gives us even more information about the devices. Okay, so it gives us the class, and this is key. If you go to the Bluetooth websites, the special interest group website, so here's the devices, and these are just the numbers, okay, and the classes of all the devices. And this is kind of the key to hacking Bluetooth, is to understand that Bluetooth devices are basically telling us what type of device they are. Here's a better one. I got another one up here for you. And you can see the classes, and the ones that we just pulled up a minute ago, right, were speakers. These are all peripheral devices. So when you connect to a Bluetooth device, it tells the other device that's trying to pair with it what type of a device it is. Is it a wearable headset? Is it a joystick for Nintendo, like this one is here? It's a portable game controller. It communicates to the other device what it is. Notice that this one here is a keyboard. Its device is class 002540. That means when you connect to this Bluetooth device, it says, I'm a keyboard. Allow me to send keystrokes, okay, into your system. And there's really no way for the system to check if that's real or not. So this is what Elliot takes advantage of. In the show, he uses a device called Multi-Blue. They don't manufacture them anymore, unfortunately. But basically what it is it's a Bluetooth device that communicates, okay, that I am a keyboard. If you have a Bluetooth-based keyboard, I'm working on a Bluetooth keyboard right now in this show. That's what this device does, okay? It says, I'm a keyboard. Let me send keyboard keystrokes to you, the other end of the connection. Elliot uses this, which used to cost, I think I bought mine for about $35. But basically, once again, it's a Bluetooth dongle that has been basically flashed with a different class, okay, a class that says, hey, I am a keyboard. So Elliot, what he does is that he gets Darlene to kind of flirt with the cop. It's social engineering. Elliot is in a car nearby. Okay. Bluetooth has a capability of connecting up to like 100 meters. He's within that range and he's able to connect to the Bluetooth device in the police car. He uses a tool called SpoofTooth. It's also, I believe SpoofTooth is in the repository, so let's just quickly take a look and see if it is. And let's put in install in there. There it is. So it's already installed on my system. Just like you can spoof an IP address or you can spoof a MAC address, it allows you to spoof a Bluetooth device. So what Elliot does is that he goes and spoofs the MAC address of one of these devices in the policeman's car. Does a scan like we did here. He gets the MAC address off the Bluetooth in the cop car, and then he spoofs it. Okay, here's the synopsis. Bluetooth-I device, and then specify a new BDADDR, right? And that's what we want to do. Let's go ahead and create this. It's pasting in the MAC address, and then it's the dash N for name right here. Specify the new name. Okay, dash N, and then it's going to be car 5537. So what we're doing is we're assigning a new MAC address and a new name for that device, and you can see it came back and said, "Hey, address has been changed." Oh, and it came back. We said the address was changed, but it can't open the device. No such device. It dropped the device, it looks like. So let's try reconnecting it again. Yeah, see, it's dropped the Cambridge Silicon Radio. Let's go ahead and try that again.
I think the lesson is, like you've always said, it's stuff doesn't work perfectly the first time. That's reality versus TV, yeah.
Exactly. Yeah, this is actually notice here that it's down. When I went and reconnected it again, it's down. So what we have to do is go HCI config, HCI 0 up. All right. Up. Okay, now when I do HCI config, you'll see that it's up.
Reality, and that's what I'm glad to see you doing this, because it's reality for all of us. Yeah.
Yeah, so there it is, up and running. All right, so we're going to try this command again to be able to spoof this. So we're going to go ahead and run the HCI tool, and then we're going to scan. One of the things that I have found is that by using here we go, we got both of those devices. Sometimes the virtual machines will drop the devices that are external, okay, and that's what we're dealing with here. But so we got both of them up, we scanned. Imagine that one of these is car 57, all right, and then what we're going to do is then we're going to try to spoof it. We're using HCI 0 as our device name. This is the MAC address we're trying to spoof, and we're going to name it car 357. Hopefully VirtualBox doesn't drop our adapter. Let's go ahead and do it. It just dropped it. I could hear the sound of it dropping it. It did change the address. You can see that the device has been changed to 7C96D2088636. And if we didn't drop the adapter, it would also rename it so that it appears, not only does it appear technically by the MAC address, but it also has a name that is recognizable, human readable name that would be recognized by the police officer. So this is the way that he goes ahead and spoofs the Bluetooth device. Now, this particular hack was done in, about 2014. And some of the early Bluetooth, you could do this type of spoofing. In the more recent Bluetooth, you're going to have more difficulty doing this because they're going to be able to spoof it. You're going to have to pair them. And even though you spoof the device name and the MAC address, you're still going to have to pair them. So it's going to be one extra step there that they don't show in the show. So he's now got himself inside the police car's laptop.
So was he spoofing the keyboard? Is that right? And that's what he was trying to do. Is that correct?
He's taking the keyboard, that multi-blue device, and he's making the laptop believe that it's a Bluetooth device that's already connected to his system. Because normally, when you want to connect a Bluetooth device, you have to pair it, right? And you have the pairing process. What he's doing is saying, okay, I am the device that's already been paired on the laptop. And then once he has that pairing taking place, now he can use this device to inject commands into the cop car's laptop. And that's where things get interesting and maybe a little bit unrealistic. So what he's doing now is that now once he's inside the cop car's laptop, he's inside the network of the detention center of the jail. So now what he has to do is he has to be able to inject commands into the prison, the jail, to be able to open up the doors. This is a little bit unrealistic. Normally what you would do in a situation like this is you would go and you would find the wiring diagram for that particular device. And they're almost all online. Here's a block diagram of the PLC. These are almost all the same. The diagram is the same. Here's the one that's often used in the prison system. This is a Siemens Cymatic S7 1500, which was actually the same one that was used in the Stuxnet attack.
So that's what was used to open and close the doors in the prison in the movie, so-called, yeah?
This is what's open and close the doors in the prison, right? So these are just programmable logic controllers. This is one of the most widely used in the world. Here's the prison diagram. This is a typical prison diagram. Each one of these are housing pods, and then there's an equipment room, which usually contains these PLCs, and a central control. Inside this equipment room, this is where the PLCs are, and they control the opening and closing of the doors in the prison. Now, all of this kind of information is available online if you look in the right places. No matter who's making these devices, they provide this kind of detail about their systems so that the users can program them properly, maintain them properly. This is basically a simple diagram of the opening and closing of the doors within this prison. Elliot could do this, right? But it still would have taken him days, weeks, months to do this process. And he does it in a matter of hours. It is possible. It's out there, right? If you go to the manufacturer's websites, and usually this will be included in a document that'll be like 150 pages long, a PDF document that you can go ahead and dig through and figure out how these systems actually work. And then the next step he has to do is that he has to go ahead and write a ladder logic program to control the PLCs. Ladder logic looks something like this here. Yeah, I teach ladder logic in my SCADA class, and we use Trilogy, which is a training educational software for doing ladder logic. This is simple logic to run the various devices in a plant. So you're reading a device, waiting for the information to come, then you're opening a valve or closing a valve. This particular circuit right here is running it, and then it takes a step through and it waits 5 seconds on the clock, and then it makes a manual decision, okay, either to open or close, and it finishes that circuit, and then it goes through each one of this is called ladder logic because it goes through this circuit and then this circuit and then this circuit. So this is really relatively simple stuff. The only issue is that you have to understand what circuits you're actually working with within the system. And that's why it's really unrealistic to expect that Elliot did that in a matter of hours. One of the things that could be done, okay, is that you could just scatter a bunch of commands into the system and see what happens, right? That's a possibility, but that would probably be detected. Now, I will just kind of give you a hint that, that's something that can be used in cyber war is that you can just send random commands into these systems and see what happens. And if it explodes, then you know you did the right thing.
What's unrealistic about that is he's connected via this Bluetooth keyboard or fake keyboard, and he's injecting a whole bunch of stuff with no visibility of what's on the other side. Is that right?
Right. He has the only visibility he has is that he could pull up this schematic. This would be available to him. He could pull this up online and find this schematic. And you can see that all the circuits are detailed here. So you can see door fully open, L3, LS3, LS2 is device fully locked. LS4 is the door fully closed. And then we have the speeds are LS5 and LS6. So this is available to him online, but then he has to write the ladder logic to be able to control each one of these various circuits to be able to open and close the doors. And notice that in the show he talks about, well, let's open up all of the doors, and that way nobody will be able to connect this to me or you. All this information is usually available online. This is available for one particular prison system that I found online.
It's crazy that you can just find this stuff.
they've got to do this for their clients, right?
Yeah.
And no matter what PLC you're talking about, whether it be Siemens or Schneider Electric, they have these diagrams, these PDFs online that give you a total breakdown of how the system works. Let's take a look at one other thing. Is that one of the things I did is use some Google dorks to find some of those cymatic PLCs. Here's the dork I used right here in URL portal MWSL. These are PLCs that are connected via TCP/IP. Right, that's why we can connect to them. And we can go ahead and find these things online, and let's find this one right here. Here it is. Anybody anywhere in the world can connect to this S7 1200. Remember the one we looked at a little while ago was the S7 1500. It's a similar model, not exactly the same, but we can go ahead and look at its diagnostics. We can get its serial number, so we know exactly what PLC this is. We know its hardware number. We know what firmware it's running. And this is without even logging in.
You literally just typed something in Google and you found this. Yeah.
Exactly. Just here it is right here. It's just used. Let me go back and show
So just
you.
for everyone watching, I've had to blur this because of YouTube rules. So I've blurred a lot of this, but but the
I'm
information
sorry.
is there. No, don't worry, we'll just blur it out. That's fine.
We didn't hack it. Okay,
No.
this is available to anybody. This is just the portal that the PLC provides to its users. And so what we're doing is just using the same portal. And notice that we haven't logged in.
Yeah.
Right? This is what's available.
It's like going
anybody.
to a website, yeah.
It's like going to a website. Exactly. I haven't logged into anything. Okay, you can see it looks like this is a check system. That looks like check to me. So it's amazing that all of this stuff is
IP addresses,
available.
it's crazy.
Yeah. And here's the watch tables, user-defined pages, the home page of the application. Okay, it takes us back to the plant, so we can get more information. That looks like check to me. I don't know, but I don't read check, but it looks like it. In any case, so this is just one Siemens, and this is one that has the portal available for the maintenance and control of this particular PLC. I don't know what plant this is connected to, but these are available online for anybody who wants to go ahead and read them. So this puts here it is, looks like it's a farmer custom fructo plant. I guess this is all going to get blurred out.
Yeah, no, we'll have to blur it out. But I think the point is, on the previous video where we spoke about SCADA, we had some comments like, we don't connect our SCADA systems to the internet. And you've just shown, like, there's one straight away. It took you like 5 seconds. Yeah.
Yeah, there are millions of them connected to the internet. Now,
Yeah.
I give the people who said that credit that theirs are not. Okay.
Yeah.
So some plants are not, but most of them are online. Like the prison is offline for good reason, right? The prison. So that's what made Elliot's job so much more difficult, is that he had to get inside the network. But many of them, you don't have to get inside the network. Not only can you see them through their portal, but you can connect to them through their maintenance port and send commands in and be able to read memory. So you can pull out the memory contents. You can send commands in to many of them. And so this is why I'm so concerned about SCADA, is that so many of these facilities are online and they're not well protected. And this is a good example of one that anybody could go ahead and just pull up online. And there's literally millions of them, and you can use Shodan to find them. You can use Google Dorks to find them, and you can connect right to them and pull all the information you need to be able to then go ahead and study how they operate, get the schematics for it, and then be able to read its memory. And many of them, you can read their memory and get the passwords that are built into memory, just like Mimikatz. So Mimikatz, if you're not familiar with it, folks, is a tool that allows you to pull the memory out of Windows system. And once you pull out the memory on a Windows system, Mimikatz then can parse out the password in memory. The same thing applies here, is that once we are able to pull the memory out of the system, then we can pull the password, we can parse out the password from memory. So these systems are all vulnerable. Not all of them. Let's be clear. Many are vulnerable to attack. And Russia is learning this at the very moment, at this very moment, Russia is learning how vulnerable their systems are to this type of attack.
For everyone watching, obviously because of YouTube, we can't show everything here, but you cover this in your courses, don't you?
I do. Yeah, and we have this course coming up in September. So I usually teach this course once a year. It's kind of one of the specialty courses that we offer at Hackers Arise. Is one, I teach you how these PLCs work, so you have a understanding of how they function, and then we look at various ways that they can be exploited, and then also how you can make them safer. And there's many ways of exploiting these systems, and one of the things that we haven't even talked about is that because these systems usually cover many acres, sometimes miles, kilometers, right? There has to be communication across these vast distances. Oftentimes, the communication methods, whether it be Wi Fi or cellular or what have you, are also vulnerable to being hacked. Once again, the issue that Elliot had was that he couldn't get inside the network. So even if the system's offline, okay, say the system is offline, and if it's a system that has to cover vast distances, and like most of these facilities do, they're huge plants, they have to communicate. And running cable isn't realistic, okay? Especially running cable in a system that has a lot of EMI. So what they do is they use various communication technologies to communicate the different parts of the facility. And those communication technologies are not all, many of them are vulnerable to attack. Once you're inside the communication, then you're inside the facility, you're inside the network, and then you can literally send commands inside of the plant and wreak havoc.
I'd love to show more of this on YouTube, but I don't want to lose my channel. So I would suggest all of you go and go look at Hackers Arise. You've got Occupy the Web. You've got a bunch of stuff like blog articles and stuff on your website where people can see some information, or they can sign up for like your subscription. Is it the $37 a month thing? Where
it's $32.99 a month to take the live courses, and the SCADA hacking course is included in the live courses that are coming up in September. So you can sign up, and that'll get you into that course. We have Metasploit coming up next month. We have web app hacking coming in July. I don't remember what we have in August, but we do have SCADA coming up in September.
I think for everyone who's watching, please give us feedback. What would you like to see from Mr. Robot or other types of hacks? I think one that we've had feedback on was the hacking CCTV one. A lot of people were saying, like, show us a demo. So maybe we can put up a camera somewhere, or you've got some cameras and we can show how to actually do the practical part of like CCTV or IP camera hacking rather than just talking about it.
I can show you some real cameras I can hack.
Yeah, the problem is I can't show that on YouTube. That's a frustration. It's like I'd love you to do it, but I mean, if it's a system that we have permission to look at, or it's a system that we own, then we can demo it. I know you can do this, but I mean,
we've hacked a lot of cameras in Ukraine, and I try to put one of those up every day on my Twitter account for people to see. Mostly, I put it up there for the Russians to see. Okay, the idea is hey, look at we can watch you. Okay, we can see you. If you continue your bad behavior, then we will be able to focus on your faces and bring this to the International Criminal Court. It's not that hard to do. What we need to do is maybe set up a lab so we can do it actually for the YouTube channel. I have a student who has volunteered his lab, so we'll have to make arrangements with him.
Yeah, that'd be great if we can do that in another video. Unfortunately, we cannot hack anything that we don't have permission to attack. So for our next video, which Mr. Robot video or show would you like to cover, or which technology would you like to cover?
We can do some steganography where he hides all his data in his CDs. I thought one of the most intriguing ones at the end of the show when he traces the Dark Army. So he uses memory forensics to be able to trace the Dark Army. That was a good one. That was really complex. It's not going to necessarily be interesting to a lot of people, but I liked it. What people might like is using the Raspberry Pi, where he goes inside of the storage facility and he connects a Raspberry Pi into the HVAC system.
We said they're like 40 hacks or something we can go through. So
there's a lot.
I'd vote for those two. But
okay.
Everyone who's watching can vote for something else. Let us know what you want.
What people will also like is how Angela used Mimikatz to steal her boss's password. And one of my favorites is how Elliot hacked the cell phones of the FBI, which actually is,
That would be
yeah,
a good one. Yeah, I like that.
that's not hard to do, really. So what he did is that he used a device that acts as a cell tower. They put it under one of the desks, and the FBI was in there doing their work, and they connected to the cell tower, and he was able to listen into all their conversations. And surprisingly, it's not that difficult if you have physical access near the person that you're trying to hack, and they were able to intercept all of the phone calls. To me, that the power of being able to intercept phone calls is really, and that's a lot of power. And it's one that people don't realize how easy it is to do.
I think we've
So
got a lot to cover. We've got a lot to cover. Yeah.
we got a lot to cover, right? And one of the things at some point in the future I'd like to do with you is this software-defined radio.
Yeah, I really like that actually. Yeah, software-defined radio would be great. Yeah.
Yeah, and we're doing a class in software-defined radio in July. Yeah, we can do like maybe a simple software-defined, like intro to software-defined
Yeah,
radio, and do
that'd be
some
great.
real basic stuff, and then maybe do later on do a more advanced one.
Occupy the Web. I'm going to keep you busy for a long time. Really, thank you for sharing your knowledge. Appreciate it.
I enjoy it. Thank you. Thanks for having me.
So everyone, look forward to a whole bunch of Mr. Robot's sort of videos coming. Give us your feedback, stuff that you'd like to see. I think we've got a long list, and hope you enjoy it.